Right, grade 10s. In this lesson, we're going to be looking at the concept of the gradients of parallel lines. Okay, so we're going to focus on parallel lines and focus on the gradients of parallel lines. What do we know about the gradients of parallel lines? We'll have a look. What we can do is let's have a look at these three parallel lines. Let's start off with the gradients of AB. Now, if you remember, how did we work out the gradients of AB? Well, we said the y of B minus the y of A, which was 4 minus 2, divided by the x of B minus the x of A. It's 5 minus negative 4. So it's 5 minus negative 4. So what did this come to? That was 2 over 9. So the gradients of AB is 2 over 9. Wow. What about the gradient of CD? Let's have a look at that. The gradient of CD would be, well, it's 1 minus negative 1. It's the y of D minus the y of C, divided by the 6 minus negative 3, which is 6 minus negative 3, which is 2 over 9. So the gradient of CD is then clearly 2 over 9. Now notice they're exactly the same. I wonder what would happen with the gradient of EF. Well, let's see. If we look at EF, it's negative 3, the y of F minus the y of E, which is negative 3, subtract negative 5, and we divide that by 3 minus negative 6. So what does that give us there? That's going to give you negative 3 plus 5 is 2 over 9. Look at that. All these three lines are parallel, and the gradient of AB is equal to the gradient of CD equals the gradient of EF. What a pleasure. And the lines are all parallel. So what do we know? Parallel lines have equal gradients. So that's the important conclusion, is that parallel lines have equal gradients. Okie dokie. Alright, that's the first important principle in this lesson. What about another concept which we talk about is called perpendicular lines, when lines run at right angles to each other. In other words, this is a 90 degrees there, and this is 90 degrees. What do we know about the gradients of perpendicular lines? Well, let's explore this a little bit. What is the gradient? Let's start with AB and CD. What is the gradient of AB? Well, I think it's exactly the same as the other one. It should be 2 over 9, but let's check. It's 4 minus 2. If we subtract the y's, 4 minus 2 divided by 5 minus negative 4. 5 minus negative 4, which is 2 over 9. Do you see that there? Okay, that is the gradient. You say the y of B minus the y of A divided by the x of B minus the x of A. And don't forget it's 5 minus negative 4. What about the gradient of CD now, this line? Well, let's have a look. The gradients of CD is going to be the y of C minus the y of D, or the other way. The y of D minus the y of C doesn't matter. So let's go, or let's do this. Let's go y of D minus 3 minus 6. Okay, so it's minus 3 minus 6. Okay, negative 3 minus 6, and then 3 minus 1. 3 minus 1. So what's that? That's going to give you negative 9 over 2. They're not really equal. Let's check the gradients of CD again. It's negative 3, this one, minus that, divided by 3 minus 1, giving you the gradient of CD. Now what's interesting here, they're not equal, but what do you notice? If you multiply them, you're going to get 2 over 9 multiplied by negative 9 over 2, and that comes to negative 1. The 2's cancel, the 9's cancel, and you're left with negative 1. So it seems like the gradients of these two lines, when multiplied, give minus 1. I wonder if it'll work with the line EF and GH. So let's look at the gradient of EF quickly. The gradients of EF would be, okay, let's move it up quickly here. The gradients of EF, if you take the y of F minus the y of E, would be negative 5 minus 1, negative 5 minus 1, all divided by, so it's negative 5 minus 1 over the x of F minus the x of E, which is negative 4 minus negative 1. Negative 4 minus negative 1. And what does that all come to? Well, that's negative 6 over negative 4 plus 1 is negative 3, so that's 2. Okay, now what would the gradient of GH be? Let's have a look. That's the other line, the gradient of GH. Well, it's the y of h minus the y of g, so it's negative 1 minus negative 5, negative 1 minus negative 5, all divided by, okay, so it was negative 1 minus negative 5. Now we do the x's, negative 6 minus 2. Let's go here, negative 6 minus 2. So what's that? That's negative 1 plus 5 is 4 divided by negative 8 for the bottom guys there. And that simplifies to negative a half. Now watch this. The gradients aren't equal, but when you multiply the gradients of these perpendicular lines, you're going to get 2 multiplied by negative a half. And guess what? That is negative 1. So when you're dealing with perpendicular lines, the product of the gradients, the gradient of AB multiplied by the gradient of CD equals negative 1, and likewise the gradient of EF multiplied by the gradient of GH will then also equal negative 1. So what is the conclusion here? Parallel lines have equal gradients, but the product of the gradients, of perpendicular lines equals negative 1. The product of the gradients of perpendicular lines is equal to negative 1. Okay, so let's explore another example quickly. What I'm going to do in this example, I'm going to give you 2 line segments. Okay, so in these examples, the first one, A, I'm going to give you a line segment AB. And A is going to be the points negative 1, negative 3, and B is going to be the points 2 and 1. Okay, so that's one line segment, AB. Okay, and I'm going to give you another line segment that passes through C and D. So C is the point 4, negative 1, and D is the point 7, 3. This is a line segment. So you've got the line segment AB and the line segment CD, and you want to know, by using the concept of gradients, are these lines parallel or perpendicular, or maybe neither? Okay, so what we do is we work out the gradient of AB firstly. Well, what would that be? Well, gradients of AB, y of B minus the y of A, so it's 1 minus negative 3 over 2 minus negative 1, so that's 4 over 3. What is the gradient of CD? Well, it's the y of D minus the y of C, 3 minus negative 1 over 7 minus 4, the x of D minus the x of C, which is 4 over 3. What do you notice? The gradients are equal. So the gradients of AB is the gradients of CD, and they both equal 4 over 3. So therefore AB is parallel to CD. Okay, because parallel lines have equal gradients. Okay, now number B, have a look here. I'm going to give you another line segment, and this is going to be the line segment AB, which passes through 1, negative 3, and the other one is B2, 1, so that's the one line segment. The other line segment is C being negative 3, 1, and D being the point 1, 0. And we want to establish, are these lines, is AB perpendicular to CD or parallel? Well, what is the gradient of AB? Well, y of B minus y of A divided by x of B minus x of A, which is 4 over 1, which is 4. What's the gradient of CD? Well, it's the y of D minus the y of C, x of D minus the x of C. 0 minus 1 divided by 1 minus negative 3. So that's negative 1 over 4. Now what do you notice? They're not equal, but when you multiply the gradients, you're going to get 4 for the gradients of AB multiplied by negative quarter for the gradients of CD, and guess what? It comes to negative 1. The conclusion, therefore, is that AB is perpendicular to CD. Okay, if they weren't equal, and if the product of the gradients was not equal to negative 1, the lines would neither be parallel nor perpendicular. Okay, I think it's time for a practice example. Let's have a go at this one. Okay, here's the practice example, guys. I want you to write down the gradient of a line, which is parallel to another line. Okay, so you've got a required line here, the gradient of a line which is parallel to the line passing through the points A and B. Now, and then the other thing is to say, find the gradient of the line which is perpendicular. That's important to the line passing through the points A and B. Okay, so what I want you to do is try this quickly, this practice example. Let's lift it up there. Write down the gradient of the line which is parallel. So in other words, the line we want, okay, there's the required line, and it's running parallel to a line passing through A and B, and the points are given. And in the B part, you've got a line, a wanted line, a required line, and it's running perpendicular to a line passing through A and B. Now tell me what the gradients of our required line are. There's the line that's running parallel to AB and the line that's running perpendicular to AB. Okay, what are the gradients of those lines? Have a go. Let me move that up and then see if you can do it.